Hello again. Today at Ontario High School we are going to be talking about drawing particle diagrams using both monoatomic and diatomic elements. With that, let's go ahead and get started. The first thing we need to talk about is what exactly is a diatomic gas. A diatomic gas is one of 7 elements in the periodic table. These elements in their natural form have 2 atoms per molecule instead of most elements that only have 1 atom per molecule. If we look at the periodic table, we see that the diatomic gases are highlighted in red, except for bromine and iodine, which are also diatomic gases. The final column, clear over to the right-hand side, they are not diatomic gases. They include helium, argon, and a couple others, but those are also not diatomic gases. Let's look at the following example. Avogadro did experiments in the past where 2 volumes of hydrogen were added to 1 volume of oxygen and formed 2 volumes of water. The problem with this diagram is that if we say that hydrogen and oxygen are monoatomic, then we only get 1 volume of the final gas. This is wrong because we know that these gases are diatomic, and we should get 2 volumes of our water instead of just 1. If we draw the diagram the correct way with diatomic molecules, we get 2 volumes of our water. It is important to note that each box should always have the same number of molecules. In this case, you can see that the boxes are the same size and contain 5 different molecules. The number of molecules of each element on the left-hand side should also equal the number of molecules of each element on the right-hand side. As you can see on the left-hand side, we have 20 hydrogen atoms and 10 oxygen atoms. On the right-hand side, we have the same number of each atom. Go ahead and pause this podcast and try this one out on your own. Make sure that you have the same number of molecules in each box and that you have the same number of atoms of each element on the left-hand side of the equal sign as on the right-hand side of the equal sign. Here is how we should draw it. As you can see, we have 10 nitrogen atoms on the right-hand side and the left-hand side, as well as 10 oxygen atoms on the right-hand side and left-hand side, because both elements in this case are diatomic. We can count the number of each element in the final compound on the right-hand side of the equal sign, and we get a formula of NO, because there is only 1 nitrogen per molecule and 1 oxygen per molecule. Let's try one more. This one's a little bit harder. Go ahead and pause the podcast again and try this one on your own and then compare your answer. Watch out to see which elements are exactly diatomic and which ones are monoatomic. Just be careful. If you got the right answer, you should have written this down. Fluorine is a diatomic element and aluminum is a monoatomic element. We'll have 30 fluorine atoms on the left side of the equal sign and on the right side, as well as 10 aluminum atoms on the left-hand side and on the right side. We make 2 volumes of our final product, which has a formula of AlF subscript 3. You have to make sure that you watch out for monoatomic elements as well. In these problems, we will always give you the correct number of boxes, no matter what, because you don't know exactly what compounds these elements will make yet. You'll eventually figure this out, and you'll learn this in future units, but for now, we will make sure to give you all the boxes in the beginning and the end of these kinds of problems. I hope this podcast helped you learn these problems. As usual, we will end with a quote. The important thing in science is not so much to obtain new facts, but as to discover new ways of thinking about them. That does it for this podcast at Ontario High School. Good luck, and have a great day.